because you know that the basic...
now we actually see visual from
yes,
the ground.
This is an infrared video image from the ground station. We can see the bright spot is a re-entry capsule. We can see the long trail is, as Professor Zhang has already mentioned, is the plasma produced by the high temperature.
So is this in atmosphere now, the return capsule?
It's already in the atmosphere.
Yeah, because we can see the long trail now, right? Yeah. Oh, the capsule is in the blackout zone. So for this stage, we cannot see live feed out from the capsule itself.
Well, we wouldn't see the videos even after the separation because the antenna is on the service module.
Right.
But now even the radio is cut off.
Look, you can see that just
the bigger, brighter
the beautiful view is the debris of the propulsion module, because it do not have a heat protection. So it will break into pieces with a
burnt out
in the atmosphere. And burn out. So this is like a meteor shower. So it's very beautiful.
Yeah, quite an exciting moment.
Oh, great. We've already seen the deployment of the parachute. Look the beautiful view. So the main parachute has already been deployed. At this moment, it's already below, the altitude is below 10 kilometers.
10 kilometers,
So at this moment, we can say that the astronaut is already safe enough.
Yeah, and that, I guess that's partially why now this spot is looking much bigger.
Exactly.
Compared to earlier stages.
What you see is not the capsule itself.
It's a huge parachute. It's a huge
parachute. So the total area of the main parachute is more than 1,200 square meters to the trajectory, especially after the deployment of the main parachute.
Yeah. Now, I think they've just disconnected the main parachute, right? And opening another parachute?
Sorry, I made a mistake. So that's the drag chute. So this is the main parachute.
Oh, this is the main parachute.
Exactly.
Okay, now obviously we can see this is optical. This is not infrared. So I believe if we are on the ground, with the sky is clear, and we can see that with our naked eye, right?
Exactly.
Yeah.
So this is a view, I believe this is a big camera, but also, as you mentioned, we can witness of the whole parachute and the re-entry capsule with your naked eye.
Yes, and as it entails on the upper right corner of yours, the landing is quite imminent.
Exactly. So to expose the 4 rocket motors. And you know that even with this huge parachute, it's still too fast when touched down. So that is the reason why we need 4 retro rockets. When the distance between the vehicle and the Earth is about 1 meter, we will ignite the 4 rocket engines, and the speed of the vehicle will slow down to slower than 2 meters per second.
So the control could be that precise, just 1 meter above, with this 3-ton payload, just when it's only 1 meter, and the ignition will happen.
The ignition, very good question, very professional. You know that just on the bottom of our re-entry capsule, we have one device called gamma ray altimeter. So it will emit gamma ray to the ground, and with reflection, it have a receiver to measure the time. So we can have a very precise measurement of the distance between the bottom and the ground.
Sorry, is this in vertical mode right now? Because it looks straight up. With the parachute on.
Yeah, so the parachute, the parachute bay is actually off an angle, which is why initially it was tilting a little bit. As Professor Yang was just mentioning, they have another rope to pull it up. So
now that's the discharge of the
propellants,
fuel,
hydrogen.
Yeah.
Because it's
for safety precaution.
It's toxic, but it's necessary. You see that, as I mentioned, it is a controlled re-entry. So as Professor Zhang mentioned, we can control the attitude of the capsule during the re-entry. This is the function of the propulsion module, propulsion system on board the re-entry capsule, but only change the direction in the roll direction. To change the direction of the lift. With the change of the lift, we can change the trajectory to the landing point.
So it's not falling through atmosphere; it's flying through it.
Flying, yes.
And the engine is basically, as like the aircraft wings changing the flipping up and down.
Right.
It's doing that function.
Right, but so I believe for a high-stake mission like this, and earlier I think we saw footage from the ground team, from the ground vehicles. They're also heading to the
landing point. So we can have a very clear view of the parachute and together with the
because it's getting closer and closer, right?
Closer.
We don't need to zoom like 100 times to take a closer look.
Yes.
And the whole, the full recovery of your sense to ground gravity would take even much longer, right?
Yeah. At this moment, also there is another critical step to just read the seats of the 3 astronauts. Because you know that to absorb the energy of the impact.
Since you mentioned this, I must ask. Earlier you said it's the number 2 to cut the rope of the parachute. When you say cut the rope, you mean pressing a button or actually doing some standard maneuvers in that capsule to do that?
Well, you know that as we discussed, the wind is very, very dangerous for the whole landing procedure. And not only during the descending procedure, but also you know that after touchdown, the wind can be a big problem. So it can drag the whole capsule to a different place. So if it is in the mountain, it will be very, very dangerous. So it is necessary to
cut the rope. Cut the rope. You mean pressing a button to do the thing, or actually you have to do a standard maneuver?
You know that, as I mentioned, the seats will be raised to absorb the impact energy. So the position of the button will be different when the seats are raised. So this is a difficulty and a challenge for 02 to conduct this operation. It will touch down soon.
Yeah, very soon. It's only about 500 meters above the ground.
It is just pushing the button. It's not going to go out there.
No.
But
impossible.
If it didn't manage to do that, somebody would jump off the helicopter and actually do that, cutting off.
At this right moment, the velocity of the capsule is less than 10 meters per second, but still too fast for the astronaut for the touchdown. So the retro rocket,
they've just adjusted the coordinates of the specific landing position.
They're just announcing. I mean, this is the fourth prediction.
And I believe the calculation is in real time, right?
Yeah, exactly. So the ground team, the whole ground team will be guided by this prediction.
This is totally within approach if you're standing on the ground, right? Yeah. Really, really close. Yes. Wow. That's designing really well.
So the retro rocket will ignite soon.
So this is optical, right?
Yes, this is
from the helicopter.
From the helicopter,
right?
Yeah, it's already above the re-entry capsule.
Yeah. Since you mentioned earlier, the terrain looks indeed a little bit different
from the
common to the common landing site we've known.
Yeah. So it's more close to the Badan Jilin Desert in my homeland, Inner Mongolia.
Oh, it's about to land.
Yeah. Oh, we can see the shadow.
Yeah. So cut the rope.
Ignition.
Oh.
Great.
Let's see if it's Now, the Shenzhou-19 return capsule has landed in Dongfeng landing site in northern China's Inner Mongolia region again. This just happened. The Shenzhou-19 crew has returned to Earth 3 taikonnauts and now on the ground in northern China's Inner Mongolia region. So far, this has been a successful landing, right,
as you
gentlemen?
As we already discussed, you may notice the rope connecting to the parachute has already been cut down.
Yeah.
So this is a very successful touchdown.
Yeah.